Okay, so in last class we were discussing about the partial differential equations, and in partial differential equation I already told you about the cases where there was a wave equation. Then even I took one case in which there was a damping. So now I want to give you a classification of general partial differential equation. So please write here general partial differential equation. Okay, general partial differential equation. So the general form of equation is given by AUXX plus 2BUXY plus CUYY is equal to f of x, y and ux, uy. Okay, this is the general form of the equation x, y, ux, uy and of u itself also. So let us understand what do you mean by this. Uh, the x and y are the independent variables here. The x and y are independent variables. So the meaning of this is double derivative in x, single derivative in x and single derivative in y, double derivative in y, and this is that external force which I was telling you in the case of harmonic oscillator. For example, you had an external force, so that force may be very complicated. As you can see, that force may be a function of x, may be a function of y, may be a function of single derivative of u with respect to x, single derivative of u with respect to y, and without derivative. So these all are the dependencies of the external term. Okay, so this is the general form. So I can categorize the type as this, the type, and then the defining condition, the type, the defining condition, and we should also write an example. Okay, type, defining condition, and an example. So here write first one, the hyperbolic, then write parabolic, and then write elliptical. Okay, hyperbolic, parabolic and elliptical. And what are the defining condition? So if AC minus b square is less than 0, then it is hyperbolic. If AC minus b square is equal to 0, then it is parabolic. Then it will be known as parabolic. And if AC minus b square is greater than 0, then the equation is elliptical. And what are the example? So this can be wave equation, which we did, and then heat equation, and then Laplace equation. So this is the general categorization of the PDE into these three forms. So for example, we wrote wave equation as this: uxx is a square uxx is equal to utt. No, we wrote this: a square uxx is equal to UTT. Correct? So in this equation, let us now correlate with this. The value of capital A is suppose A square, and this is like UTT, the second variable. So it will go this side. So it will become uh, the value of C will become some uh, -1. Correct hai? So AC, and what is the value of B? B is 0. So A into C is less than 0, which is correct, because A square will be always positive, because the value of A square is always positive. The value of A square is always positive. So this equation is hyperbolic equation. So in this way you can categorize every equation into this. We may have taken A square as 1 to just make you understand how it is working. Suppose I take A square 1, so 1 into -1 will be less than 1. Correct? Got this point, everybody? The categorization between the hyperbolic, parabolic and elliptical. So any of the equations, we can tell whether the equation is a hyperbolic equation, a parabolic equation, or an elliptical equation. Let us check the Laplace equation also. So let me check the Laplace equation. So for example, the Laplace equation is given by uxx plus uyy is equal to 0. So the value of capital A is equal to 1, but the value of capital C is equal to -1.
+1, sir.
Sorry, is equal to +1. So 1 into 1 is greater than 0. This is okay. Correct? So this is the simple category, and the heat equation. I will teach you in some time. But the heat equation actually we solved. Like you had u of xx is equal to some u of t. Such equation is known as heat equation. Double derivative in position, but single derivative in time. Okay, so that I am going to come. So that I will teach you. Don't worry. Okay, so if you see this, this will be parabolic in nature. You can see that it will be parabolic in nature. ये भी देख ही लो.
How a square x minus 1 has become negative?
You tell why it will not be negative.
Sir, a square is positive, but x is variable.
A square is positive and -1.
It's negative.
So what is your question?
Sir, this is always negative. This has you have written this.
No, what is your doubt?
Sir, how a square x minus 1 is negative?
Where is x yaar? This is multiplication. Into के लिए कुछ तो लिखना पड़ेगा. Okay. So this was just a general discussion. So just अगर ये पूछ लिया जाए कि in what category the equation will fall, so we should know that in what category the equation is going to fall. Okay, correct? So let me erase this. So let us come to actual point. I mean the actual type of equation. So after this, let me consider a heat equation to solve. Okay, so let me consider a heat equation to solve. Heat equation. After the wave equation, let me consider a heat equation, a simple heat equation, and that is given by C square Uxx is equal to Ut. This is the simple one-dimensional heat equation. Correct? And this time you can also check what will be the dimension of this C square. C square into 1 by L square will be equal to 1 by T. So dimensionally C square will be L square T minus 1, and if you take this it will become half. So that means it will become Lt to the power minus half. This will be the dimension of this C. Okay, so this is related to the conductivities of thermal conductivities of not exactly thermal conductivity, but this will be thermal property of the material through which the heat is supposed to flow. Okay, so this was just for your information, and we will start from here. So C square Uxx is equal to Ut is the heat equation that we want to solve, and it is very obvious that the value of T will be greater than 0. Okay, so let us try to solve it. So you understand the technique, you already know. What is the technique? It is the variable separable technique. So the technique is variable separable technique. Let us try to solve this equation. So what I will take, u of x comma t is equal to capital XX into capital TT. Correct? This is the variable separable technique. So it will become c square t x double dash is equal to uh, x t dot, and if you divide it, it will become x double dash by x is equal to uh, t dot by c square t, and this should be equal to sum minus lambda square, and so it will become x double dash plus lambda square x is equal to 0. This is the first equation, and dt by, I mean, we can write it in this term also, t dot plus lambda square c square t is equal to 0. Okay, so these are the two equations. The first one will become x1 is equal to c1 cos of lambda x plus c2 sine of lambda x. This is the solution of capital X, and this is given by, you can see this, dt by t is equal to minus lambda square c square dt. Can you see that? So after integration, it will give you ln of t is equal to minus lambda square c square t plus c. Okay, so what is the value of t? It is c 3 times e to the power minus lambda square c square and t, and let us not write it c but k because c is already there. Now what is the solution? Tell me. So this kind of mathematics is very important for physics, because you know, most of the time your equations in physics will be some form of partial differential equation. So if you are okay with this, you are okay with Schrodinger equation, you are okay with many other equations coming in physics. Okay, so u of x comma t is given by c1 cos of lambda x plus c2 sine of lambda x into c3 is absorbed here. Okay, c3 is multiplied to these constants, and if you don't mind, I will just write it a and b for simplicity, and this will become e to the power minus lambda square c square t. So this is our solution of one-dimensional heat equation. Okay, this is our solution of one-dimensional heat equation. Now we want to take a particular case uh, in which there is a bar. So consider a bar, okay, at 0 degrees Celsius. The bar, a bar, ends of the bar are at 0 degrees Celsius. The ends of the bar are at 0 degrees Celsius. So it is something like this. X is equal to 0. X is equal to L. Okay. And this is kept at 0 degrees Celsius. This is also kept at 0 degrees Celsius. The ends are kept at 0 degrees Celsius. Okay. And we have to know, and this surface is insulated. So it is actually lateral insulation. Lateral insulation. It is laterally insulated. Okay, the bar is laterally insulated. Now you see how we can handle such type of problem. So we know that this will follow the heat equation. So its solutions are like this. And what is here? If you see 0 comma t should be equal to 0, because this end is at 0 degrees Celsius. And what about this end? L comma t should also be at 0 degrees Celsius. So this boundary condition suggests that x0 should be 0, and this boundary condition suggests that xl should be 0. This type of boundary conditions I have already taken in the wave equation. Okay, so you understand that first you will write the product, but tt will not be 0 because that is a general term. If that becomes 0, everything is 0. Okay, similarly that side also. So we will take always a particular, the term which is given at a particular point to be 0, not in general. ये clear है सबको? यहाँ तक कोई doubt हो तो बताओ. Is this much clear to everybody?
Yes, sir.
Yes, sir. Okay. सो देखो, ये सब चीजें जितनी कॉम्प्लिकेटेड दिखती हैं उसके क्वेश्चन उतने ही आसान एग्जाम में आते हैं, और बहुत बहुत बार पूछा जाता है पार्शियल डिफरेंशियल से. सो इसलिए ये कंप्लीट पैकेज आप प्रिपेयर करते हो तो आपके 3-4 क्वेश्चन हो जाते हैं. ऑर्डिनरी डिफरेंशियल इक्वेशन, समटाइम्स 2 क्वेश्चन, समटाइम्स 3 क्वेश्चन. ओके, and then comes partial differential equation, one question. Then comes special function, one question. And then comes Green's function, that is advanced part, so always 5-mark question. So this way it is a very major part. Okay, this complete part is very very important. और मैं बहुत ही concentrated form में पढ़ाता हूँ, तो ये नहीं कि इसमें बहुत बहुत ज्यादा आपका टाइम लगा रहे हैं. बहुत ही कॉन्सेंट्रेटेड फॉर्म में वी विल स्टडी, और क्वेश्चंस उसी के अराउंड आते हैं. ठीक है, ओके. सो प्लीज सी दिस. Let us make this x0 is equal to 0. This part is x0. Huh? We know that this part is x0. So x0 is equal to 0, so 0 is equal to a. So this suggests that my x will become just b sine lambda x. Correct? Applying the boundary condition. And आज बहुत पैसिव होके पढ़ रहे हो भाई आप लोग, क्या बात है? ये पूरा समझ आ रहा है या बिल्कुल समझ नहीं आ रहा है, क्या हो रहा
आ रहा है सर, आ रहा है।
है? आ रहा है ना? थोड़ा
सर
बहुत
क्लियर।
थोड़ा बहुत कुछ ना कुछ रखा करो ताकि लगे कि हाँ मैं किसको पढ़ा रहा हूँ। बिल्कुल
यस सर, यस।
पिन ड्रॉप साइलेंस भी नहीं होना चाहिए. ओके. So now let us see this side. XL is equal to 0. So let me put here. So 0 is equal to b sine lambda L. So now b cannot be 0, because if b is 0, xx is 0, then everything is 0. So we will take lambda L is equal to n pi. So lambda is equal to n pi by L. Lambda is equal to n pi by L. Correct? So now apply it here.
सर
Hmm.
सर ये e टू द पावर माइनस लैम्डा स्क्वायर सी स्क्वायर टी वाली टर्म नहीं आएगी क्या?
कहाँ नहीं आएगी?
ए के मल्टीप्लिकेशन में हमने x को 0 पुट किया है, तो
हम्म.
साइन लैम्डा x तो 0 हो गया और कॉस लैम्डा 1 हो जाएगा, तो a इंटू मल्टीप्लाई बाय e टू द पावर माइनस लैम्डा स्क्वायर सी स्क्वायर की टर्म भी
ये
आएगी ना.
ये क्या लिखा हुआ है?
x t इज
जीरो।
x. तो क्या ये x में है ये पार्ट?
नो।
हम्म.
x में नहीं है.
तो आप बाउंड्री कंडीशन तो आप x में लगा रहे हो, यानी कि इसमें लगा रहे हो. वो
ओके,
C1 C2 को मैंने a भी लिख दिया था, बट
थैंक यू सर.
आई एम अप्लाइंग हियर ना. दिस इज x, xx, and this is tt. I
ओके
mean
सर, थैंक यू.
constant is adjusted here. Constant is adjusted here, huh? So my this thing will become ux comma t is equal to, now because n की बहुत सारी values true हैं, so I will have to take the linear combination of all, so it will become n is equal to 0 to infinity. And please see this, that a is gone, so only b with this will remain, so just write it as this bn, and e to the power bn sine of n pi x by L e to the power minus n square pi square uh, t n square pi square c square, n square pi square c square t upon L square, upon L square. So this is the solution for this. Okay. And now some initial condition will be given to calculate this. These are the boundary conditions that are given. These are boundary condition, and with this some initial condition will be given. So for example, let me write it here. Suppose they have given that ut of x comma 0 is equal to some f of x. If this will be given, this is initial condition because it is given in time. It is known as initial condition. This will be given, and using this condition, this bn will be calculated. Okay, you know the Fourier concept. So I will first calculate ut of x comma t, that will be given by summation n is equal to 0 to infinity bn, and sine of n pi x by L into take derivative with respect to t. So what will come? Minus n square pi square c square by L square into e to the power minus n square pi square c square t by L square. Correct? Now write this as fx will be given by summation n is equal to 0 and bn into this minus n square pi square c square by L square into e to the power minus n square pi square c square t by L square. Correct? And this term will become 1. This term will become 1 and sine of n pi x by L will be there. So now this is a Fourier series. This is a Fourier series and I told you the method to calculate the value of Bn. So both sides this sign will be multiplied and then it will be integrated in the limit. So 0 to L fx sine of n pi x by L dx is equal to Bn into minus n square pi square c square by L square into इसका square हो जाएगा, so that will come out to be L by 2. Correct? Upper limit by 2. So the value of Bn will be written here. Okay, this will be the method that we will follow to calculate the third boundary condition. Is that okay? And if only ux comma 0 is given, इसको तो हम लोग actually gx लिखते थे. Let me please इसको change कर लो, gx है. If this is given, this is actually gx. And what was fx? If only ux comma 0 is given. I mean they are just notation, but I am following the same notation. So इसको erase कर रहा हूँ. So if only this thing is given, suppose, so it will be known as fx and that will be much easier to write because you can write it directly. Fx will be equal to, so fx will be equal to summation n is equal to 0 to infinity and bn sine of n pi x by L. So this is a very simple Fourier series. It will be given by fx into sine n pi x by L integral 0 to L dx is equal to Bn into upper limit by 2 L by 2. So Bn will be equal to 2 by L integral 0 to L fx sine of n pi x by L and dx. So this is the way how the Bn will be calculated. So most of the time this will be given. This is the initial condition. Because it is given at t is equal to 0, so that's why it is known as initial condition. And what is the U in this heat equation? That U can be heat, can be temperature. For example, it can be temperature. In this case, it is temperature, na? Because you are given here temperature is 0, here temperature is 0. Calculate the profile of temperature. So it is temperature. U is temperature profile in this question. Okay? Tell me if everything is okay. Note down. And if there is any doubt, you can ask. Clear है भाई सबको? It is clear? So let me take a question then. This was the derivation of the topic. So let me take a question. This is not required. Now only this is required. So the question is like this. You have a bar like this. This is x is equal to 0. This is x is equal to 80 centimeter. This bar is laterally insulated, and here and here the temperature is 0 degrees Celsius. The sides are kept at 0 degrees Celsius temperature, and the initial temperature is given. That means Fx is given 100 sine of pi x by 80. This is given. And we have to find out the value of ux comma 0. That is question mark. So let us try to solve this. A very good problem. And the value of c square is already given. The value of c square for a material is actually k by sigma rho. So for copper it is given to be 1.158 for copper. K is thermal conductivity, rho is density, sigma is specific heat. So you can note down K is thermal conductivity and rho is density and sigma is specific heat. Specific heat. Okay.
सर
Hmm.
जो फाइंडिंग है वो ठीक लिखा गया, देखना एक बार नोटिस।
क्या क्या फाइंडिंग?
सेकंड लाइन में
नहीं 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 नहीं, ये थोड़ा गलत लिख गया है। यू एक्स कॉमा टी, आई मीन this is the general profile na. So we know that this is the solution when the ends are at 0, correct? This is the solution when the laterally insulated one dimensional rod is kept and the ends are kept at 0 degrees Celsius temperature, and then this is the profile. So let me write the profile. U of x comma t is equal to, लिखना, summation n is equal to 0 to infinity, and bn sine of n pi x by 80 by L e to the power minus n square pi square c square, which is 1.158 c square t by L square, t by 80 square. This is the situation. Now we are given with this. So 100 sine pi x by 80 is equal to Bn sine n pi x by 80. This is the condition that is given at t is equal to 0. So you can compare this as n is equal to क्या है, 1 है, correct? Yes or no? There is no other term. N is equal to 1. बोलो भाई.
Bn is equal to 100. Yes, sir.
N is equal to 1 and the value of B1 is equal to 100. Correct? So U of x comma t will become, now no summation because all other terms are 0. All other bn's are equal to 0 because see left hand side there is no other term to compare. So U of x comma t will become 100 sine of pi x by 80 e to the power minus pi square into 1.158 into t over 80 square. So this is the solution. So इसको जब थोड़ा सा कैलकुलेटर से सॉल्व कर लोगे तो दिस विल बिकम 100 sin pi x by 80 into e to the power minus 0.001785. आपको हाथ से कैलकुलेट करना आना चाहिए, स्क्वायर करना, डिवाइड करना, ये सब चीजों की प्रैक्टिस आप अपने लेवल पे ही करना। तो ये बड़े आराम से 5 मार्क्स का क्वेश्चन बन सकता है। तो दिस वाज पार्ट ए, ओके। एंड पार्ट बी है, प्लीज राइट, हाउ लॉन्ग will it take for the maximum temperature in the bar to drop down 50, drop down to 50?
सर प्लीज रिपीट कर दीजिए।
How long it will take for the maximum temperature of the bar to drop down to 50? अब ये बड़ा इंटरेस्टिंग है, हमें वो समय निकालना है जहां पे मैक्सिमम टेम्परेचर 50 बन जाएगा। तो प्लीज सी दिस, व्हाट इज मैक्सिमम ऑफ दिस? तो फर्स्ट ऑफ ऑल तो लेट अस राइट इट, वी वांट व्हेन इट विल बिकम 50, so I should write it as 100 because maximum की बात हो रही है। So this amplitude will uh, oscillate, but it will, its maximum value will be 100 and e to the power minus 0.001785 t, so it will become uh, 0.5 is equal to uh,
सर इसको log 1/2 कर लो सर।
इसको ऐसे लिख देता हूँ, log of 2 is equal to 0.001785 t, okay, and this is
सर
0.93.
तो सर
हाँ भाई बोलो।
सर ये log 1/2 हो जाएगा ना, इधर 100 ले आएंगे तो 1 से लिफ्ट हो जाएगा ये।
क्या बात है भाई, अनुज जी बताइए क्या कह रहे हो?
सर मैं इसको ये कह रहा हूँ कि ये वो 50 है, ये 100 है हमारा, इसे इधर ले आएंगे तो log 1/2 हो जाएगा सर ये हमारा।
इधर क्या हो जाएगा? log
1/2।
तो फिर उसको log 1 माइनस log 2 लिख लो, log 1 0 हो जाएगा और इसका माइनस इस वाले माइनस से कैंसिल होगा। सब मैंने कर दिया मन में ही, आप और कर लो।
ओके
So t will become 0.693 over 0.001785। कोई बताना जल्दी से कैलकुलेटर से।
388.2
हम्म
388.2
388 सेकेंड, okay, so this is the another part. So after 388 सेकेंड जिस भी जगह का मैक्सिमम टेम्परेचर होगा that will become half of its. So maximum temperature at some point will be 100, where this will become pi by 2, this value pi x by 80. You can calculate what will be that location, that also you can calculate. Pi x by 80 is equal to pi by 2, correct? So this will become cancel, so x will be equal to 40 centimeter. So at 40 centimeter, suppose this is x is equal to 40 centimeter, here the temperature will be 100 and they are asking, tell me when this will become 50. So after 388 second it will become 50, correct? So for this chapter, for this partial differential equation chapter, I am following Erskine. So this is very nice problem from there. Okay, you can see from Krasik or Erskine. Few problems are there, but they will make your level so that you can attempt questions in exam without any difficulty. Correct? And for further also, for your future career also, it will give you a lot of understanding. So I think this part is now done, and solve same question. I am giving you a homework. Same question, solve same question when u of x comma t is equal to 100 sine 3 pi x by 80. Same question solve karna with this. So different, I mean this is x comma 0. So different fx can be given and the question will change. This same one dimensional problem will change for different values of fx. अलग अलग fx लिख के अलग अलग क्वेश्चंस बनाए जा सकते हैं. समझ आई बात? Okay. So now I will take this discussion in next class.
सर
किसी को कोई डाउट है तो पूछ लो. हाँ भाई बताओ मनोज.
सर बी पार्ट में ये जो जैसे 50 तक ये लेके आना है ड्रॉप डाउन,
हाँ
तो ये इक्वेशन जो लिखी है आपने 50 इज इक्वल टू 100 e टू पावर, इसमें साइन वाले टर्म वाला वो समझ नहीं आया.
भाई तुम्हें मैक्सिमम टेम्परेचर को लेके आना है 50 पे. तो
ओके
मैक्सिमम टेम्परेचर क्या होगा तब ये चीज मैक्सिमम होगा.
जी.
तो ये चीज मैक्सिमम क्या होगा इसकी वैल्यू 100.
ओके साइन इक्वल टू 1. ठीक
ठीक है ना.
है. यस सर.
वो जो तुम्हारी हाई स्कूल ट्रिग्नोमेट्री है वो यूज हो रही है. बस बात है कि हीट इक्वेशन में यूज हो रही है ना.
ओके सर.
ओके वेरी गुड. तो पूरी चीज रिवाइज करना. ये जितने क्वेश्चन मैं पार्शियल के करा रहा हूँ उसको सबको दोबारा से आप करके देखोगे. ठीक है.
एक्सक्यूज मी सर. सर बुक का नाम रिपीट कर दीजिए.
सेम बुक है. बार बार एर्फकिन और क्रेजिक दो ही किताब है जिसके अराउंड पूरा मैथमेटिकल फिजिक्स चलेगा. ठीक है. ये आफ्किन है. ओके. बट बुक में बहुत ज्यादा मत अभी जाने की कोशिश करना. थोड़ा उसको रखो रेफरेंस के लिए. इफ देयर इज एनी कंफ्यूजन यू कैन सी. उसको ये नहीं कर सकते हो कि तुम एक तरफ से शुरू करके खत्म करो बिकॉज देयर इज नो टाइम फॉर दैट. हाँ. So this exam is about ki how quickly we can learn up to that standard which is required in your exam, but very quickly and with great brevity. बहुत ही short में. Because जब एग्जाम आपका पास आने लगेगा तो पार्शियल के लिए आपके पास शायद हाफ एन आवर भी मिल जाए रिवीजन के लिए तो बड़ी बात है. तो यू हैव टू रीड इट राइट नाउ. You have to clear your concepts right now so that when that day comes you just quickly half an hour में मतलब एक दिन पहले जब आप रिवीजन करते हो तो that day you will have 9 topics. So how much time will you give to one topic of mathematical physics? 10 minutes, 15 minutes. So you will just learn it right now. Then only you can revise it in 15 minutes and go to your exam. Okay. That is true for every topic. So अभी जब आप पढ़ रहे हो तो ही आपके पास वो आखिरी समय है जब आप अच्छे से पढ़ रहे हो. आगे जैसे जैसे आप बढ़ते जाओगे फाइनली तो रिवीजन के लिए एक एक टॉपिक के लिए बहुत कम टाइम होता है. तो अभी जो क्लैरिटी होगी दैट विल वर्क देयर. ओके. ओके देन थैंक यू. हाँ
Thank you, sir.
थैंक यू.
Thank you, sir.